Now we're going to take a look at how the other properties of logarithms come into play. You might be familiar with some of them from just deriving them from the previous section, but just in case, we'll take a little bit of a quick review. I always like kind of posing them in English. It helps me remember what's happening. So if we're looking at the first property, when the base matches the argument of the log, the answer is 1. So we'll go from there. The other thing, if next property down, if the argument is 1, no matter what the base is, your answer is 0. And you kind of have the idea, if the base matches the base of the logarithm that's located in the exponent, your answer is whatever the argument was happening to be. So that doesn't always make sense just looking at it, but sometimes we can use these properties to help us with some of the more complicated expressions. And most of the time when these properties show up, they're not so straightforward. So sometimes we have to do a little bit more thoughts, or how do you say, a little more tricks to help us rewrite them in forms that we know. So we'll take the next few examples all together so that you can kind of see how we utilize them. So starting off with them just wanting us to find this value of x. And yes, 8 times the natural log of e squared. Maybe there's a better number for that. So the first thing I'll kind of look at is the fact that I have a natural log, and that's the log that I want to inspect a little bit more. Remind myself that the base of a natural log is e, and they don't always write it in there, so I'll write it in there myself. So right away, this kind of gives me a little bit of an idea that we're dealing with property number 1 in a sense, because the base is the same as the argument. Is also e. So that's kind of the idea of log base b of b equals 1. But before we do that, we don't just see this in the statement. We do see an argument that has an exponent. So you're kind of pulling in for the other properties. Maybe it might be nicer to say, well, I need to see this first. This too needs to be pulled along to the front so that we could actually see this property being utilized. So I have the 8 that's already there. It's going to be multiplied by the 2 that gets pulled in front. And then now we have natural log of e. And again, that base is e. So this now allows us to see that, yes, we do have that property where the base and the argument are the same. So the value of this expression would be a 1. So it gets multiplied by 1. And then you're looking at what's really already there, 8 times 2 times 1. So the actual value of this expression is a 16. So that's one way to do it. Sometimes you start seeing these a little bit faster. You don't have to write as many steps, but take your time, get comfortable. Let's play with the next example. So another one of those asking us to solve for x, even though it's already solved for x, but the idea is they probably want us to simplify it. There's probably a better way to write this guy. So if I'm looking at it right away, I see a logarithm in the exponent spot. So what I might pull up for myself is just to remind myself of the property. That might be b to the log base b of x. I know that that's going to equal whatever the argument is, but I can't quite utilize it yet until I see the pattern. So a lot of times when these look a little more complicated, you may just say, well, that base of that log, even though you can't see it, that base, it's not written, the base is 10. So it would be ideal if I had 10 as the base for both of these so that I could come up with some sort of conclusion. And at least I have that base right here, that's 10. But I also see this cube root of 1000. And that's just a fancy way to say cube root of 1,000 is 10. So kind of tricky in a way, but it made us think about it twice. So let's rewrite this expression. We still have the 9. Instead of cube root of 1,000, we'll write a 10. That's kind of nice. And that 10 is taken to log of 5. And now this allows us to use our property. So again, if you could kind of see this property right here. We have 10 taken to the log base 10 of 5. And what that tells us is that that whole result is always equal to whatever the argument is, the bases match. So all of that would be rewritten as 5. So we still have the 9 being multiplied. X equals 9 times 5. That gives us 45 as the result. So a little tricky, but take your time, simplify what you know, and see if you can match it to a property. Let's take a look at example 6. Right away, from our past experience, we do see radicals. And anytime you see radicals in the argument, you may want to rewrite it so it has rational exponents. So let's do that. 12 times log base 5, instead of square root of 5, that is 5 to the power of 1/2. Bless you. So now I'm starting to see, I could kind of pull through my arguments. Log base b of b, it looks like the base is somehow matching the base of the argument. So I know that's automatically going to be equal to 1, but before I can utilize that, I need to get rid of that exponent part. And how we do that, that has to do with one of the previous properties. It moves along to the front as a coefficient. So we end up having x equals 12 times 1/2 log base 5 of 5. And now we see what we're looking for. If I can highlight that for you. Log base 5 of 5, right away we can replace that with a 1. So we now have 12 times 1/2 times 1, which in the end ends up being 6. That's a nicer way to rename who our x is. One more example to help us out. Right away, you see that you have a logarithm in the exponent place. So this brings me back to my property. Whenever I have a logarithm in the exponent spot, I'm looking for the bases that match so that the answer will be the argument. That's that third property that we saw. So let's make that look a little bit more like the property. I still have the 2 that's there. I have base of e, natural log of 6.5, still equal to x, so that we can make this match a little bit more. Remember, I can write that little base in for the natural log. And now I see right away, all of this will be replaced with just the argument, which is 6.5. So there's still the fact that there was a 2 that's multiplied to that entire statement. So 2 times 6.5, that is going to leave us with 13. So that is 13. So I hope that this gives you some experience with how we are utilizing these 3 properties. Feel free to practice a little bit more with the homework, and then I'll see you in the next section.